I got this, and then I typed that in.
Your history?
Yes.
Oh.
You don't I gave okay. Continuing charge stuff. What's the matter?
Kramer, I got the right alternate angle, and then I subtracted 28.8 for absolutely no reason. I got the wrong angle.
So he had good logic.
So I could have.
Don't hurt me.
Yeah.
Kramer, don't worry. If you,
Well, that's on camera.
That's going in the
Help
speech
us.
for graduation.
Yeah.
oh, but this man only works by good logic.
Backhand.
Kramer, it's so loud I can't focus.
Nice.
It's okay.
I really enjoy this.
Send everyone out
You
there.
don't realize what this does to you later in the day.
Kramer, it's okay.
That's what drives you guys have had a really rough home life.
You can't afford paper. Things are rough.
That's a pretty
Okay. Electric potential energy. Here we go. We are now going to kind of continue on with charged particles, but we're going to more talk along the lines of like electricity and dealing with how electricity is used to power lights and whatnot. So, and the next chapter is my favorite chapter, circuits. Circuits.
I know, I thought you said that. The one that was about light, what's the one you said was your favorite?
You talking about with the mirrors?
Yeah.
I like that stuff. That's not my favorite though. So you guys remember the mechanical energy that we did back in like chapter 4 and 5, where we had to do the kinetic and the gravitational potential energy and the elastic potential energy. Let's now add electric potential energy.
I actually gotta be honest, I actually don't remember.
Peggy or right here, dude. Peggy was the
Oh, yeah, okay.
So we learned that when two charges interact, an electric force happens between them. So just like you would have potential energy associated to gravity, you can have potential energy associated to two charged particles. So if you remember, gravitational potential energy was primarily determined by what?
Height.
Yeah, distance or height. Okay? And just as you would imagine that height affects gravity's potential energy, where the charged particles are in a particular electrical field will determine how much potential energy it has.
So you're saying that the amount of energy
Yes. The amount of energy is definitely dependent
Funny
on
how Coulomb's law works like that.
goodness.
You know, I got the wrong answer by good logic, but that doesn't really mean anything. And then I got the right answer by that.
If you got the wrong answer, it wasn't good logic.
That's relative. You realize that when you do this, it doesn't make us want to root.
Okay, let's go.
Oh, I don't. You already didn't want to root for me.
All right.
Because of the
I'm allowed
Just
to
keep
have
it
them.
Oh, we love you.
Yes, you are, Colin. That doesn't make it right.
Anyone's opinion, right?
Oh, you're
It's their
probably blocking the
opinion.
board.
All right. Okay.
I'm sorry, Pete.
So, electric potential energy is potential energy associated with charge due to a position in the electric field. Where you are in that electric field determines how much potential energy you have. Also, what kind of charge you have would also depend or have an effect on its potential energy. Okay? Now,
You realize some people watch this video post and look at Cole's back.
That's what I was saying.
he doesn't care. Potential energy elastic, here it is.
What did I need to read?
Okay? So the potential energy elastic is dependent upon the electric field, that makes sense, where the objects are in the electric field, and what the charge is of it. Okay? Now, I'm going to kind of give you a little chart here. Yes.
Was it displacement or no?
No, we're going to use distance in this. Now, I'm going to give you this. Honestly, I think just thinking about it logically makes no sense, but
A long eel. It's just a. Oh yeah.
Why are we losing our?
It's called.
I forgot to
We're
other
gaining
with
heat.
the end of opposite.
That's called.
It's opposite.
I realize that probably, you can get that, don't get that confused with elastic, please. I'm talking about electric in this chapter.
Oh, yes.
I got that question wrong on the test because I thought it was
Turns out I was
elastic.
trying to like.
There is heat.
Why are we still using that note card?
Why would I not be?
Because it's like.
Just go on the note card.
Because I actually care about the
It
environment.
doesn't go on a note card.
No, I'm not using the chart on the number.
Well, why don't you memorize your equations on each number?
If he was a true physics wizard, he would.
Alright guys, be quiet.
Oh.
If you feel like this would help you, you can. I'm going to kind of explain this.
Oh, that makes sense.
First of all, this is an electric field line coming from a positive going towards a negative. So this would be like if I had like two charged plates. So this was a positive charged plate and over there was a negatively charged plate. Okay? Now I think that if you understand repelling versus attracting and you understand distance, just thinking about this conceptually, you won't need that. In fact, you have to memorize this, but if you understand the concept, you won't even worry about that. Let me explain what I mean. Okay, if I were to have if the positive charge were going to go to this point here, would it be gaining or losing potential energy, and why? If it's moving from here to this point, is it gaining or losing potential energy, and why? It's going to lose. Why?
Because it's farther from the repulsive.
Okay, so this repels, right? So if I get further away from something that repels, do I have more energy to be repelled? No. Okay, if I had a positive here and I was moving closer to that point, I would be doing what? Gaining potential energy. So I'm getting closer, like, because you would have to force it closer, right? So that when you let it go, by the time it would have a lot of energy that would transfer as it moved away. Yes?
Are we gonna have to know the point in which, like, a negative won't gain any more potential energy because it's just too far away?
No. Like, yeah, obviously there's a point where it's outside of the field, yes. We'll always be doing it, we're like close to it.
Okay.
So it's just like on.
On what?
Like
On the fan.
like you know, like I don't know. Wouldn't there always
What was that?
Wouldn't there always be a little bit of electric fields or no?
For what?
Everything
Like
has
everything.
a little bit of.
Oh, probably, because there's charged particles everywhere, yeah. Okay, now,
No matter the distance, just be a
Okay, I thought-
small number.
let's say if this is a negative now. Let's think about this conceptually, okay? If I moved it from here to there,
It gains potential.
it gains potential energy.
Oh, yeah, protons don't move fast.
Oh.
How do they have potential energy? Protons don't move.
Okay?
Yeah.
If I go from here to here, I'm losing potential energy.
Wait, that's actually a good question.
What?
It's a charged particle, not a proton, but yeah. Oh wait, no. It's like how does a proton gain potential energy? It doesn't move.
We know very.
What is?
So like a proton
It's a
cannot
charge.
remove
Yeah, I know.
move within a nucleus, but can an ion be positively charged and move? Yes.
I don't know, that's just hard for me.
I understand. Yeah, it is.
That's why you don't read the book. It really gives strength.
We're just bringing up
I'm
all
sorry.
these- all these sour notes.
Back,
Yeah.
back.
Just give us all.
So is it opposite charge in that clip? It's always opposite. It has negative.
Yeah.
What?
It has to do with sign
So
convention.
sign matters now.
So are those lines?
From potential energy.
Yeah.
Have you been in the couch?
What'd you say?
Are those lines the electric field?
Yeah, the electric field lines. Yep. Could I make this a negative plate and put a positive and negative in there and think conceptually about whether or not I'm gaining potential energy or losing? So you could just do this and memorize this, but I feel like if you can understand it conceptually, you're a lot better off.
What is a long
Like with E, opposite E. These are the electric lines, so if I'm going with the lines, that would be a long E. If I'm going against the lines, that would be opposite.
Is that part negative? So the line's still going out, or it's negative?
It would be coming in. Okay. Any last questions on this? Okay, think of it like you would think about gravity. As I rise up, it's a little bit trickier than just raising a height. You have to think about, is it attracting or is it repelling? And what am I doing? Am I moving left or right? Okay, that's essentially all from this lesson. Okay, any questions before you leave?
We need to write down these equations.
In your note card? Which one?
Yeah, well, you can't.
You probably won't use the first one, but